Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video I am going to discuss how we can create Kafka Consumer using Python and also going to discuss the concept of offset commit in detail. Okay. So before going ahead with these two discussions, I will request you to first go through the concept of Kafka Consumer and Consumer Group, which I have already covered in my previous video. The links I'll be providing in the description box, because the concept of consumer and consumer group will surely help you to understand today's discussion in a much better way. Okay, so without any further delay, let's start. So let's say we are having a topic in our Kafka cluster with 4 partitions, okay, and a consumer group with 4 consumers are consuming the messages from the topic using polling mechanism. So there are a couple of points in this sentence which are very important. We are having a topic with 4 partition. That means if we are consuming the message using a consumer group, then within the consumer group we should be having maximum 4 consumers only, right? Because at a time one consumer can consume the messages from a particular partition. It is not possible that multiple consumers are consuming message from same partition. So as a result, if we are having a consumer group with 5 or 6, that is more than 4 partitions, then the extra consumers will be sitting idle, right? So here we are having topic with 4 partition and consumer group also with 4 consumer. So each consumer will be consuming messages from individual partition. That is clear, right? And here obviously, as I already discussed, the Kafka consumer follows the polling mechanism. That is, consumer request the Kafka topic, Kafka server for messages if anything existing. Okay, Kafka broker or Kafka server itself will not push messages to the consumer side. So it is not a push mechanism. The Kafka consumer follows pull mechanism. Okay, so that's what the polling mechanism is followed here, right? I hope this particular concept you can easily visualize. Now here is the pictorial representation of the same situation. So here we are having a topic with 4 partition. Okay, in the partition 0 we are having total 9 messages, 0, 1, 2, etc., indicating message offset. What is offset I have already discussed, which is nothing but unique identifier of our message in Kafka cluster, right? So in partition 0 we are having 9 messages, in partition 1 we are having 13 messages, in partition 2 we are having 6 messages, and in partition 3 we are having 4 messages. Okay, and here we are having our consumer group which is having 4 consumers, where individual consumers are consuming messages from individual partitions after Kafka rebalancing, right? So just consider at a particular instance of time, the situation is like this, where the consumer 1 is consuming the messages from partition 0. It is currently at offset 4. That is, message corresponding to offset 4, this consumer 1 has consumed and processed. Okay, the consumer 2 is in offset 8 for partition 1. Basically that means 0 to 8 all the messages it has consumed. Then consumer 3 is at offset 2 for partition 2, and consumer 4 is at basically offset 2 for partition 3. Okay, that is the current state. Suppose now, due to some reason, suppose the consumer 4 or any consumer goes down. Let's try to understand what will happen then. Okay, so there is an important characteristics of Kafka, that is Kafka never take acknowledgement from consumer. Okay, that is Kafka cluster don't have any idea that how much messages is processed by a consumer within a particular partition, or at what offset the consumer is currently consuming the messages from a particular partition. Related to this kind of stuff, Kafka cluster have no information. Okay, however, consumer API itself can take the responsibility of saving this kind of information, that up to what offset it has consumed the messages and all. That I am going to cover in the upcoming discussions. So as of now, I hope it is clear to you that unlike other messaging system, Kafka don't keep a track that up to what offset the messages are consumed. Okay, and at this point of time, suppose our consumer 4, which is consuming the messages from partition 3, suppose that went down. Okay, so now currently we are having 4 partition and 3 consumer. So obviously one consumer will start consuming messages from 2 partitions after Kafka rebalancing, right? And suppose consumer 3 got the responsibility. Okay, so after Kafka rebalancing happens, consumer 3 got the responsibility to consume the messages from partition 2 as well as partition 3. Partition 2 anyway, it was earlier also consuming. Now partition 3, which our consumer 4 was consuming, because consumer 4 is down, so consumer 3 got the responsibility. Okay. Now when consumer 3 will try to consume the messages from partition 3, it need to know from where it should start consuming. Like if it starts consumption of messages from offset 0, then obviously reprocessing of same messages will happen, because already consumer 4 has consumed the messages up to offset 2. Okay, right? So actually consumer 3 should start consuming the messages from partition 3 from offset 3, that is from this message onwards it should start consuming. Now consumer 3 don't have any information, because Kafka itself don't keep a track up to which offset the consumer has consumed. So how the consumer 3 will know from where it should start consumption to avoid reprocessing of same message? And that's where comes the concept of offset commit. Okay, this concept basically helps whenever Kafka rebalancing happens and one particular consumer get the responsibility of message consumption from a particular partition, then that consumer will get the information from the concept of offset commit, that from where it should start consumption of message, from which offset it should start. That how it knows, let me explain. Okay, so suppose we are having a partition, there are 9 messages are there, so offset value starting from 0 it is going up to 8. Okay, and this is the consumer which is consuming the messages, right? Now to keep it track up to where it has consumed the messages, what the consumer does in the backend, it store the offset till which it has consumed the messages in a Kafka internal topic called __consumer _offset. Okay, so what the consumer one will do, it will always commit the information that see up to this particular offset I have consumed the messages or I have processed the messages from the partition. If next time I goes down, some new consumer comes, it should start consuming the messages just from the next offset. It should not reprocess. Okay, so what the consumer one will do, it will basically commit the information in the __consumer offset. This is a topic which is created by Kafka only, managed by Kafka only. It is an internal topic. Okay, and suppose this particular consumer has consumed the messages up to offset 4, so it will commit that information in the consumer offset topic. Okay, right? And actually in the back end, the consumer API, whether you are using Java API or Python API, that have to take the responsibility of this information commit. The Kafka will not take the responsibility. Okay, so the consumer API in the backend has to commit the information in the consumer offset topic that up to the offset 4 it has consumed and processed the messages successfully. Okay, then after some time, suppose the consumer 1 goes down. Okay, and another consumer 2 comes up. Now it need to know from where it should start processing the messages or consuming the messages from this topic. Actually it should start from offset 5, right? So from where it will get this information, already the information is stored in consumer offset, right? That up to offset 4 the messages are consumed and processed, right? So consumer 2, which is a new consumer which don't have any information from where it should start consuming the messages, what it will do, first it will go to the consumer offset, this particular topic, and it will come to know that okay, up to offset 4 the messages are already processed. So the consumer 2 will start consuming the messages and start processing the messages from offset 5. That's how it works in the backend. Okay, so that no reprocessing of messages will happen, right? So I hope you understood this particular concept. The main important point here is the committing of offset up to where the messages are consumed. That particular offset should be committed in the consumer offset topic, and that basically controls or prevents the reprocessing of same message, right? And I hope this concept is clear to you. Actually in the backend lot of event happens. All those concepts I am going to cover slowly in my upcoming videos. As of now, I hope the offset commit concept in the consumer offset topic is clear, and it will be much more clear when I will show you the demo, right? But before going to that, I would like to cover one more concept. That is, here if you see, the consumer 2 is starting the consumption of messages from the last committed offset. Like here, last committed offset is offset 4. So it is starting the consumption of message from offset 5, right? Now, what about the initial situation when there is no committed offset? Because suppose you created a group, and within that group you started some consumer. So overall that group is starting the consumption of messages for the first time. That is what happens initially, from where the consumer will know from where it should start consumption. That how it is controlled, let us try to understand. Okay, that is how to determine the initial offset, because in the middle if something happens, we can easily understand that next time whenever any consumer spin up, it start consumption of the messages from the last committed offset, right? But what happens for initial offset? There is a property called auto offset reset, and that controls the initial message consumption. Okay, let me first show you one demo and then I will come to the property. So here what I will do, I will go to terminal and here I will start my zookeeper. Okay, so here my zookeeper is started, and then here I will start my Kafka server also, or broker, whatever you say. Right, here the Kafka server is going to start, and now what I will do, I will create a Kafka topic having the name demo testing. Okay, so here I will open the new console and then here I will paste that, and here the demo topic is successfully created. Okay, so here this particular demo testing topic I am using here in my producer code to produce messages, right? So what I will do, I will start producing messages in the demo testing topic. So here you can see number 0, number 1, number 2, like that the messages will be produced. Now I can show you the consumer in a command line interface first. So here if you see in command line interface, we can start the Kafka consumer in two ways. Here we can mention the from beginning. If we are mentioning this, then what it will do? It will start consumption of messages from beginning. That is from number 0 it will start. I can show you, just I will hit and enter. So here you can see that it started consuming the messages from number 0, and then it is keep on increasing as our producer is publishing messages, the consumers are consuming eventually. Okay, right? So this is one way of starting consumer. There is another way of starting consumer I will show you. That is, here what I can do, I can ignore from beginning, and then what will happen, once the consumer spin up, after that whatever messages producer will publish, only those messages this consumer will consume. Like here you can see up to 35 it has published, and I can hit and enter. Here you can see our consumer is now started. Now here it started consumption of messages from number 38 only. Okay, that is before the consumer whatever messages was published, that this particular consumer has ignored, because we have not written from beginning, right? So we can easily understand that we can start the Kafka consumer basically two ways. Here we can mention how we want to start initially, in the initial phase when there is no offset concept, right? Because here we are starting a fresh consumer, so there is no offset concept. So when I'm starting for the first time, when there is no committed offset, then I can start in basically two ways. One is I can configure the consumer such that it will start consumption of messages once the consumer spin up. After that, whatever messages are published, only those it can consume, or else what it can do, it can start consumption of messages from beginning. Okay, and that we can control by this particular property, auto offset reset. Okay, if auto offset reset is earliest, that means it will start consumption of messages from beginning, that is from offset 0. Okay, if we are starting for the first time when there is no committed offset, right? And if we are configuring latest, then consumer will only consume the messages from the Kafka producer, whatever messages was published after the consumer spinned up. Okay, and once we get any committed offset in our underscore consumer offset topic, then suppose we are stopping the consumer and starting that again, whatever the property we are configuring in auto offset reset does not matter, it will start consumption of message from the committed offset onwards only. Okay, so one thing, have a clear idea, once a consumer group has any committed offset or any offset written in underscore consumer offset topic, then this configuration does not help. It just helps for the first time when there is no committed offset and we want to start our consumer. Then whether we want from beginning or whether we want only the newly published messages, that we can control using this auto offset reset. But next time onwards, when we are having any committed offset, after that if we are starting any consumer, then it will follow the pattern whatever I have discussed here. That is, it will just go to consumer offset, it will take the last committed latest offset, and from then onwards it will start consuming the messages to avoid duplicate processing, right? So let's now see the consumer code here eventually. So here what I am doing, here in the consumer code, here I am importing Kafka Consumer, importing the JSON, and here I am creating the Kafka Consumer. Here I am giving the topic name, which is hello underscore world 1, and here I have configured my bootstrap server and value deserializer. So if you recall my previous video, I have already explained, right, that in consumer side first deserialization happens, because when producer is producing messages and publishing in Kafka topic, it is writing the messages after serialization, after converting the objects to bytes, right? Similarly, in the consumer side, the reverse thing will happen when consuming the messages. First it will deserialize and then it will consume in the client side for consumer, right? So here we are doing that. Here we are mentioning the deserialization as json.loads m.decode UTF-8. So if you see in producer side, we have converted the message json.dumps, we have converted to string, and then here we have done UTF-8 encoding to convert that string to bytes. Similarly, here in the consumer side, we are just doing the reverse thing. First, we are converting that message from bytes to string, and then we are using json.loads to get the JSON data or dictionary data. Then here we are giving group ID, which is demo1. So here we are creating the consumer within the demo1 group. And auto offset reset is latest. So when you are configuring latest, that means what? That means once our consumer spin up, after that whatever messages our producer published, that messages alone will be consumed for the first time if we are not having any committed offset. That means it is like without using from beginning concept in our CLI. As simple as that. Okay. So we'll monitor that impact. So what I will do, I will close this window. Here if you see, if I go to terminal, here our Kafka server is running, here our zookeeper is running, that is fine. All I will do, I will create a topic having name hello underscore world 1. Okay. And here it is showing that it is already existing. So maybe what I can do, I can create a topic with some other name. So hello underscore world maybe 3 I can put. Okay. So here hello underscore world 3 topic is created. Okay. So I will change the topic name in my producer as well as in my consumer. Okay. I will save that, and here I will start my producer. Okay. Right. So here I will run main. So here you can see it published number 0, number 1, like that the producer has started producing the messages. Now I will start my consumer. So here you can see within this particular group, maybe I can give some group name arbitrarily demo 112215 something. Now within this particular group, there is no committed offset, because this is the first time we are launching any consumer within this particular group, right? So what will happen, how the messages will be consumed when there is no initial offset, that will be controlled by this property. And here we have written latest messages only it will consume. That means within this particular group, when first time this consumer will start, then after that whatever messages will be published in this particular topic, those alone will be consumed before the consumer starts whatever messages published. Like here you can see from 0 to 25 or something, whatever the messages are published, those will not be consumed. Okay. So let's run that. Just I will run this one. Okay. And see from where the consumer is starting consumption. If I move my window a little bit in the right hand side, here you will see that it started consumption of messages from value number 31, 32 like that. Okay. So all the previously published messages are gone. Why they are gone? Because there was no committed offset. So here, because there was no committed offset, the message consumption began based on this particular configuration. And here we have configured latest. That is, after the consumer spin up, whatever messages are newly published, only those it is consuming. Okay. But suppose now if I am stopping this particular consumer and then I am starting that again, what will happen? Obviously, it will start consuming the messages where it stopped, right? Because in the back end, automatically Kafka is committing the offset in the underscore consumer underscore offset topic that is basically created in the logs. If you see, Here if I go to server logs, here you can see the topic is created underscore underscore consumer underscore offset, and it is by default having 50 partition, as you can see here. Now the offsets are committed. So now if I stop this particular consumer and start again, it will just start the consumption of messages from the latest committed offset. That is, from the next time onwards, this particular property will not play any role. But for the first time when we started, we have seen that this property played a very important role. Due to this property, the message consumption start from the latest one instead of from beginning, and that's why we basically lost the messages from 0 to 30. Okay, right? So I will stop my consumer now. Here you can see up to what it consumed. Here up to value 82, number 82 it has consumed. Okay, so if I show you here, the producer is continuously producing messages like number 88 and all. So here in the backend, because the consumer offset concept is working, so what will happen? If I start my consumer again, it will go to the consumer offset topic. It will know that okay, that is basically up to number 82 I have consumed. That is basically up to offset 82 the processing is done. So it will start consuming the messages from offset 82 onwards or 83 onwards. Okay, so here I will start my consumer again and see the beauty. Here it started consumption of messages from offset 83 onwards. Okay, so actually earlier it already completed the message consumption up to offset 82, so it is now starting from offset 83, and all this is happening due to offset commit concept. Okay, so auto offset reset equal to latest we have seen. Now let's observe auto offset reset equal to earliest. What changes we can see then? Let us try to understand. So I will stop my this particular consumer and stop the producer as well, and here I will create a new topic hello world 4, and here I can give some new group ID. Okay, and here also topic name I can change to hello world 4, and instead of latest auto offset in the consumer side I will put earliest. Okay, and in the terminal I will create a topic with hello world 4. Okay, I will hit an enter, and here you can see it is created. Perfect, right? Now only change we did, we configure auto offset reset equal to earliest. So now I will start the producer. So now the producer will start producing the messages in this topic for the first time. So here I will run. Okay, so number 0, number 1, number 2 will start producing. And now if we start the consumer, what will happen? It will start consuming the messages from the beginning. That is, from beginning when we applied in CLI, the same thing what we are going to observe now. Because auto offset reset we have configured earliest. So from beginning it will start consuming. Why I am saying from beginning? The reason is very simple. There is no committed offset currently for this particular group. Because in this group, currently I am creating a new consumer, right? I have changed the group ID. So this is a new group. There is no committed offset for this particular group. So it will start consumption of messages from beginning based on auto offset reset property. So let's see. I will run, and here if you see it started from offset 0. That is the difference in between auto offset reset equal to earliest and auto offset reset equal to latest. That is only for the first time when there is no committed offset. In the initial time only it can impact how your consumer is going to behave. Okay, and from then onwards here you can see the messages are keep on getting consumed by our consumer. As simple as that. Even I can stop this particular consumer. Here you can see it has consumed the message up to offset 35. But here you can see the producer is keep on producing messages like after 35 it has produced 36, 37, 30, 39, 40. So if I start my consumer again, basically this particular property will not at all impact, because already there are some committed offset in the backend, right? Because the Kafka consumer for Python by default does the commit thing in the backend. So obviously we are having some committed offset. So what this consumer will do, it will start consumption of messages from that committed offset onwards. So up to offset 35 we have already consumed. So we can hope that up to offset 35 it is committed. So from offset 36 onwards, now the message consumption should happen. So let's see. I will start again. So here if I go to the top, here you can see it started consumption of message from offset 35 only. So earlier it stopped at offset 35. Now it started from offset 35. That means only one message is reprocessed, which is belonging to offset 35. And after that, it has picked up all the messages when the consumer was down, but our producer was producing messages. All those messages also it has consumed, and then it is working like normally how consumer works. Okay. only one message is reprocessed, which is belonging to offset 35. And you might think why this message is reprocessed. That I am going to cover in my next video. Okay, so I hope the fundamental concept of offset committing, how to create a Kafka consumer in Python, what is the importance of auto offset reset as earliest or latest is clear to you. This is all for my this video. Just try to play with the Python code little bit, go through the documentation. You can basically explore from the documentation itself that this particular consumer API by default does auto commit. We no need to do anything. So you can understand in a better way if you just try to play with it or try to do different experiment with this code, right? So this is all for my this video. In my next video, I'll be discussing these concepts in much more detail. Till then, stay tuned. Thank you for watching.